Welcome to solverfy.
For this problem, we want to calculate the magnetic moment of a spinning sphere of charge. So there's a lot of parts, but let's start with A. So dA divided by RD times 2 pi r sine, and that's equivalent to 2 pi r squared sine. So for part B, we have dI is equal to LA divided by T, and we know T is equal to 2 pi divided by W. So then we have dI is equal to 2 pi r squared sine divided by 2 pi divided by W. And so that simples out to WR sine. So for part C, using the results from A and B gives you, let me move that down. So ADI, which would be pi times r sine squared times that WR squared. And so that simplifies to be pi WR to the fourth sine cubed. So for part D, we integrate to find the magnetic moment. So micro be pi over 0, pi r4 sine cubed theta d theta, and that is equal to pi sigma WR to the fourth, supposed to be pi in 0. So sine of theta times 1 minus cosine squared of theta times d theta, and that equals 4 pi sigma WR to the fourth divided by 3. And so sigma is equal to Q divided by 4 pi r squared, and that gives micro equals 4 pi WR to the fourth divided by 3 times Q divided by 4 pi r squared. And so that simplifies to be WR squared of Q divided by 3. For part E, we now have a solid sphere, so we need to consider the sphere to be a series of thin concentric shells, each of thickness dr. And we use the results from part D. So we have dq is equal to PR dr, which is equal to PR times 4 pi r squared dr. And d micro is WR squared dq divided by 3, which is WR squared divided by 3 times PR times 4 pi r squared dr, and that equals 4 pi r divided by 3 times integral of r0 PR r to the fourth dr. For part F, we want the G factor, so we need to use the results from part E. So 4 pi W divided by 3, the integral of R0 PR r to the fourth dr, and that's equal to G times Q divided by 2M times L, and that's equal to G Q divided by 2M times IW, and that's equal to G Q divided by 2M times CM r squared W. So G equals 8 pi divided by 3qc r squared. The integral of r, 0, pr, r to the 4th dr. So for part G, we want G if the solid sphere has uniform density. And so in this case, the integral would be r0, pr, r to the 4th dr. And that's equal to q over 4/3 pi r cubed times r to the 5th divided by 5. So if we use c equals 2/5, we get g equals 1. So there you go.